Y'all have no idea how excited I am for this. So I've been waiting to do this for a very long time. Ever since I bought my house, I've been really taking down the days and planning this out. And I think I drove my fiance slightly crazy. But I am finally wiring my house, not with measly copper Ethernet cables that are only able to do 10 gigabit. It's so slow. But now I'm wiring my house with fiber optic connections. This OM4 fiber optic cable is able to easily handle a 100 gigabit connection in duplex mode even. This thing is able to transfer so much more data than a copper Ethernet cable for actually a lot cheaper than you think. You can buy the 100 gigabit connections for this thing, the 100 gigabit transceivers for this thing, off of fs.com for about $100. By the way, fs.com sent me all this fiber and a ton of other stuff. Very thankful for them. It's not sponsored by them or anything, but without them I would not have been able to do it to this extent. But they supplied these fiber optic cables. So this right here is a OM4 fiber optic multi-mode LC to LC connection. It is what's called a patch cable. Effectively, it's been pre-terminated on both ends. And so the reason I bought this instead of terminating my own fiber is because terminating your own fiber is a rabbit hole that can cost so much more money and get you pretty poor results. Fiber is not as easy as Ethernet to work with when you're terminating it. You can't just look up a YouTube tutorial and start going. No, fiber is incredibly precise because there is a very, very, very small bead of glass in here that actually goes through and refracts light perfectly. So it's able to transmit data at insanely fast speeds while actually having an incredibly low signal to noise ratio. And so you can just have insanely long runs with this stuff, and it's actually fairly cheap. So I got these 30-meter runs from fs.com, they sent them over to me. And so what I'm doing is I'm going through and going to wire 4 of them from my server room into my network closet, my guest bedroom into my laundry room. And so that way I'll have 4 uplinks from my actual server room where I'm gonna have my top of rack switch that's gonna be capable of 10 and 25 gigabit SFP plus connections into my laundry room, which has all my network cables. Right now, the only switch in there that's got fiber uplinks is a 10 gigabit SFP plus connection, but I am planning on upgrading to 25 gigabit with that as well. That's for another date though. But I'm gonna have 4 uplinks in there so I can have 2 aggregated connections just in case I screw up and cut a line or anything like that, also getting me increased throughput. And I'm also gonna have another 4 going into my office. And so the reason I have 4 going into my office is 2 are gonna be right behind my computer so I can have a fiber optic uplink to my connection for my computer when I wanna go 25 gigabit and faster for editing and just transferring massive media. So that's for 2 of them. And then 2 of them are gonna be right behind the camera that you normally see, where I've got my dining room table with a blue wall. And so that way, if I'm testing on a product and I wanna have a 25 gigabit uplink to my network to see how fast it is, I can literally just pull a fiber optic connection down and be testing it live right there, which is gonna be awesome. All right, and so now the next question everybody's gonna be asking in the comments below. You probably already have seen dozens of them. Why? Why not just go put in a Cat 8 Ethernet cable in there? That can do 25 gigabit, that can do 40 gigabit. Well, technically the specs say it can, but there's no devices out there that support it. And when those devices do actually come out, they're going to be incredibly expensive and incredibly power hungry. Fiber is so much easier to run fast than a Ethernet cable because fiber has very, very, very low signal degradation because it's light and it's refracting almost perfectly down the tube. And so because of that, it is so much easier to transmit data at faster rates with fiber. And so the transceivers are incredibly cheap for what they're doing. And it also means that you're able to go so much faster for a lot cheaper. There are 0 devices out there that you can purchase no matter what your budget is that allow you to run 25 gigabit Ethernet over copper. That being said, copper RJ45. You can with a DAC cable, but that's a whole different ballgame. But these, you can easily buy 400 gigabit connections. Now, this cannot do a 400 gigabit connection, sadly, but that's okay. I'm able to do a 100 gigabit connection, which is actually where the sweet spot is right now. So that really just leaves me open to testing whatever I would like and having common compatibility. All right, so now with that out of the way, let's talk about what you need before you go ahead and buy your fiber. So running fiber in your house is actually really not as easy as you think it is, but it does take more planning than just something like a simple Ethernet cable takes. So there are really three things about fiber you need to make sure are consistent whenever you're working with it. One is the speed. You need to make sure the speed of your fiber, basically the category of cable you've purchased, is going to be good enough for whatever kind of connection you're doing. This is OM4, there's a bunch of versions, OM3, yada, 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 and that should work with pretty much anything you want to throw at it on small scale. This OM4 Fiber is able to do a 100 gigabit connection over 100 meters. And so that is fairly cheap and pretty easy to implement. So that's the first thing you need to do. Then the next thing you need to check is single mode versus multi-mode. So there are two different types of fiber, single mode and multi-mode. Really the only difference between the two is how large the diameter of the core is. Basically the part that's actually transmitting the light. Single mode fiber is designed where it's so small that only one wavelength of light is able to traverse it. And this means it can run very, very, very far because with one wavelength, you don't have to worry about the different diffraction indexes going through and bending light differently. Therefore, if you had multiple, they would get out of sync if you do a really, really far run. But when there's only one wavelength of light traveling through a cable, it can't get out of sync with itself because it's the only thing traveling in there. And so that's why single mode fiber is able to traverse so much further than multi-mode fiber. This is multi-mode fiber. Multi-mode fiber, however, is much cheaper in two different categories. So it is way, way, way cheaper for short runs because the transceivers are so much cheaper. Because you don't have to have an ultra precise laser to go through and fire a single coherent wave of light through the cable. Instead, you can just use an LED, which is not giving off just a single frequency of light, but actually multiple. Frequency and wavelength are the same thing, just inverses, by the way. So when I say frequency, it's because I'm used to working the frequency and not the wavelength. So whenever you've got multiple wavelengths of light going down a cable, they will get out of sync by the end, but if you're running short connections like 100 meter, that is nothing to worry about. And so that's why for most smaller runs, you're going to see multi-mode fiber being used because the transceivers are so much easier. But for long run applications, for example, I've got Google Fiber here. Google Fiber actually has a single fiber running from my house to Google's co-location facility or wherever their server uplink is, which for all I know could be 20 kilometers away. And so for that, they need single mode fiber. So that way it can't get out of sync because of the diffraction index. And so whenever you're getting fiber to the home, it's almost always going to be single mode fiber. But whenever you're going from like within a house, you're going to be wanting to use multi-mode fiber just because all the components are a lot easier. So those are the first two things. Now on to number three. Number three is the connection. So this right here is a LC connection. LC is probably what I would recommend. So LC has two different fibers, one for going there and one for coming back. So that way it can be duplex and they can talk without having to have two beams of light going down the same cable at the same way. Instead, one direction has one fiber, the other direction can use the other fiber, and so they don't have to go through and figure each other out. Instead, it's just one direction each. And then LC is the connector on the end. This, in my experience, is by far the most common connector type, and so I'd probably recommend it for you. It's going to be the most compatible. You're going to see a lot more stuff available for it, but it also is kind of a chunky top right there. So if you're trying to run it through very short things, it might not work great for you. Now that being said, any dual fiber, you can convert to any other dual fiber. So they've got converters for everything, so you really don't have to worry about like, oh no, I really want to use this special connector. I've got to rewire my house. No, you just go through and say, oh, get a $2 connector on there, and it'll change it from any single one to whatever you'd like. And so if you make sure all those match up, your fiber's pretty much good. Now onto the transceiver. So this right here is a fiber optic transceiver. This is the part that actually goes through and generates the laser or LED. Basically, it generates the light that goes down and actually creates the signal. And you plug it in very similar to an Ethernet cable. You basically plug it into your switch or your firewall or your computer's NIC, and it'll go through, and it's got an electronic connector right here, and it will convert that electrical connection into light, shooting down the end right there. So these are one of those things that manufacturers just found out that they could make some extra money on by locking down their own devices to only using certain brands. So whenever you go through and you're buying a new network card or something, you need to make sure if it's an SFP plus or any kind of fiber optic connection, you need to make sure your transceiver will work with it. Now, fs.com has a great compatibility list where they've basically gone through and you can buy any one of their transceivers with emulated firmware. So it will be able to emulate any single transceiver you choose to buy. However, you have to choose what firmware to put on there when you're buying it. So if you're buying an Intel chip, you need to make sure you get an Intel transceiver. There are guides online. You just need to make sure your specific network card will work with your transceiver. So for example, you can have a network switch that uses Cisco and a network card that uses Intel. So you plug the Cisco part into the Cisco switch and the Intel transceiver into the Intel card, and then they'd still be able to talk to each other. Now that being said, that does not really apply to DAC cables, which is direct attached copper, which are basically short runs of fiber optic connections that actually, instead of going over fiber, it just uses electrical connections similar to Ethernet cables. And the reason this works is it's super short runs. And so when you've got super short runs, you can just use DAC cables, which do not have any fiber in them, but also do not appear to have any compatibility issues with different manufacturers. So that's just a lot of information there. So whenever you're buying a little transceiver like this, you need to make sure a few things. One, you need to make sure that the end matches whatever you're plugging into. For example, this right here is an SFP28 transceiver. So that means it is able to handle 25 gigabit connections. But it also happens to be compatible with all the SFP connections as well. So this can be plugged into an SFP28, an SFP plus, which is 10 gigabit, or just an SFP connection, which is 1 gigabit. And you can go through and you can set it to any one of those and it will just work. So you can always go down, but you can't necessarily always go up. So you just need to make sure that it'll fit in the right hole and that it will work. So this is the 25 gigabit version. And so I can just plug it into the switch there and it will just work and be able to transmit at very fast speeds. And so just a few other things to know before you really start messing around putting fiber in your own home is fiber is a lot more delicate than regular copper Ethernet cables are. There is a bead of glass in there that actually can get broken, in which case your fiber will now be useless. And so you want to make sure you're somewhat careful with it. I mean, it's not just going to break. You can flex it, you can mess with it, you can put where you need to, but don't just rip it through a wall like you would with a regular copper Ethernet cable. You want to be fairly gentle with it. And the other thing about it is it's got some strange stiffness to it, just by the fact that the fiber does not like to bend very much. You also can't bend these too much because then the light will not be able to refract properly. So you need to make sure you adhere to whatever bend radius rules you've got for your specific fiber. But because of all that, it doesn't handle as cleanly as an Ethernet cable. An Ethernet cable is stiff, but malleable. Fiber is pretty free, but at the same time, just really wants to get tangled. So you just need to take it slow and make sure you're doing it right. It's not terrible, but it's definitely not nearly as easy as running Ethernet cables. The other thing is, if these connectors on the end, you can see it's got two little end caps right there. If I take these off and I was to touch the end, that would really dirty the fiber, which it might still work, but you would likely have worse signal performance. So you want to make sure to keep those end caps on at all times until you're ready to plug it in. And you really don't want to get that dirty. Be careful with it. It's not like you have to have a clean room to work with the stuff, but you just don't want to be touching it if you don't have to, because they're pretty difficult to clean. You can't just like wipe it on your shirt or anything. Instead, there are special static cleaners for these that I don't actually have. I've not had any issues with it, but you just need to make sure to have them clean. The other thing is, fiber is shooting a laser or an LED, but it is shooting very bright light down the line. Do not look at the fiber. You want to make sure to keep the end caps on until you're about to plug it in, and then don't stare right at it because it can blind you. It is not like you need to have like laser goggles on or anything like that, but you should make sure you know, don't stare down it and leave the end caps on just so you make sure. All right, and so now with that out of the way, let's go ahead. I'm gonna show you where my first 4 runs are and how we're gonna do them and finally get them fully set up, which is something I've been very excited for. So luckily, I went through and ran all my fiber 2 days ago. It was 110 in my attic, so that was not fun. But now it's currently snowing out there, so that's northern Alabama for you, I guess, where it was super hot one day and now it's snowing like 2 days later. But thankfully my first 4 runs are done, and those are the ones from my actual server room into the networking closet. And so I want to go over those. All right, and so now we're getting up close and personal with each other because this is my guest bedroom and there's just no room to film in here. And the current box is on the floor, so it's very hard to get a good angle on this. I apologize. But what we've got here is, if you look right back there, I have 4 of my 8 fiber optic cables already terminated back there. And so actually the way I terminated those already terminated cables is just something like this. This right here is a little junction box that basically has a LC female end and an LC female end on both sides of it. And it fits in a keystone panel. Now these janky ones I purchased, there are now better ones out there, and now fs.com actually sells them. So I wish I had just gotten them from them, but at the time they did not. They sell ones that actually fit in keystones. These right here have these little blue sides on them that I actually had to saw off every time I want to use them, because otherwise the 2 of them hit each other because they are too wide to fit in a standard keystone panel. And so this is what I'm using. You basically just plug in the end of the cable right there in the wall, which I've just dropped down from my attic, and then I'm able to go ahead and plug them in. And so then we can see we've got this connection right there coming in here. I've got my excess fiber right here, and then it comes in right here into the box. So I'm just gonna go ahead and pull out my phone so we can see this better. Right back here, we have the fiber optic connections, and you can actually see this spare cable in the wall back there. Then we go back in, we can see the cable coming through, then we can see it being plugged in right here. So this right here is a transceiver. And so I'm gonna look away, but if I pull this out, you will actually be able to see the laser in there. But we can go ahead and plug this back in so my network goes back up. And so that right there is the uplink. And you can see I've just tied off the extra patch cable right there, and it goes right back into the wall right there. And so this way, I'm able to switch out whatever I would like back here. Then the way we go through and add another cable in, so we go ahead and pull off the 2 connectors here. I'm just gonna go ahead and pull those 2 off. Make sure to keep those. Then pull off the 2 dust covers. Go ahead and plug those in. Go ahead and just pull it on through and add in a new connector. So from this new connector, we're going to want to go ahead and just pull off the dust cover on the actual device. Plug in. And now, remove your dust covers on this device. And once again, while averting your eyes, plug in the fiber optic cable. So just like that, the fiber is now plugged in. And so now we're going to go on the other end over there and set her up. All right, and so now we are over in my network closet, and as you can see right up here, I have my 4 fibers coming down, and then they plug into these 4 patch panels right here. Then they go into this enterprise switch right here, which is the Unify USG Enterprise 24, which has 12 2.5 gigabit PoE plus ports on it. So you can see this is currently my 10 gig uplink, but I want to go through and set up with link aggregation to get twice the overall throughput of the device. And so I've already gone through and already on my switch, gone through and set up these 2 ports as aggregated ports on both here and also on the main switch. So now we just need to go ahead and hook these up. So now we've got a little patch cable right here that's very small, just long enough, and another 10 gigabit transceiver. So what we want to do is we want to figure out which of these ports actually has the device. So what I can do is, covering them up, we will see with the camera which one of them, by removing the dust covers one at a time, has light shooting down it. So you can see right there, I got super lucky, and the very first one actually was the one that had it on there. So now we can go ahead and just plug that in. Just gonna go ahead and remove the dust covers here. And once again, averting your eyes, go ahead and plug it in. All right, and so now the end of this is also going to be that laser. So you may or may not be able to see it, probably not, but I got it super clear on my phone. So just taking off those dust covers, I'm going to go ahead and add in this guy right here. And so now we've got this connected. Now it's all about just taking off this guy. And going through and plugging them in. All right, and so now you can see they are both flashing. And so now the way this should be working, and the fun way to test it is, what should happen when I go ahead and unplug one of these is it should still actually work. So what I'm gonna go ahead and do is start a speed test on my phone here. So my phone is currently connected via Wi-Fi to the rest of the network. So now to figure out if this works, we're gonna go ahead and test it out by seeing what happens to this speed test. All right, so the speed test is running. Now let's unplug the fiber cable. And the speed test never stopped. That means that this was all successful and that we have two 10 gigabit connections aggregated together. Now this is way more uplink than that switch needs at all, but it means that we've got the ability to have a fiber cable be cut or anything like that and still retain that uplink. Then if I had enough devices to saturate the 10 gigabit connection on one of these, I would actually be able to have fully 20 gigabits of connections for this, which is awesome. And so this is my fiber setup. You can see the patch panels right here that I've gone through and set up the connection with, and they're just plugged into the fibers coming down from my ceiling. But this is a great setup. So right here, I have one additional slot for a switch, and my plan is to actually buy the 10 gigabit switch from Unify that has 12 10 gigabit connections on there and two 25 gigabit SFP28 connections on there. Those would then be uplinked via the fiber and SFP28 connections to my top of rack switch, which I'm planning on also buying the enterprise top of rack switch from them. I'm gonna spend a lot of money from Unify in the next year, and be able to have 25 gigabit connections to here. Then in my office behind the computer, also have a 25 gigabit capability is going to be so nice to have. All right, well that's going to be it for this overview and my exploration in fiber optic connections. Go and leave any other tutorials you'd like to see me make, and any other things you'd like me to test out with this fiber connection. Have a good one, bye.